Scientific notation, named as such because scientists use it all the time. Well, why do they use it all the time? What is it? These are great questions we're going to discuss right now. First thing I'm going to do is I'm just going to, as I'm chatting, how are you doing? How's your day going? Did you eat anything good today? Did you sleep well? Good hygiene out there? How's it going? All right, stop. This is a series of numbers that, if all connected, technically represents some number. It's a number so large that I don't know what name I would give it. I don't even think this would necessarily have a name. It's a number so large that you would not know what to do if you had that much money. You could probably never spend it. It goes far beyond millions, far beyond billions, far beyond trillions. And yet it exists. And even though we don't use it, we need to know how to write it. And the amount of time it took me just to write all these digits down was far too long. And that was just for this number. What if I had a number twice this size? What if I had a number 10, 100, 1,000, a million? What if I multiplied this by itself? You can see where I'm going. Numbers get very large very fast, and we need a way of writing them that's not what I just did. Same thing with numbers that are very small. If I had a decimal point and I was to stick, I don't know, 1,000,000 zeros in front of that 5. If I was to try and answer the question, how many grains of sand fit in the entire ocean to cover every bit of water that's there? That blows my mind trying to figure out what number that would be. But there's a number, it exists. How would I write that number? Scientific notation is what we use to write those numbers. And here is the basis for it. Times 10 to some power. That is a terrible 10. 10, there it is, better, to some power. Now that power might be positive, like 6. It might be negative, like -6. Why times 10, you may be asking? Because if I multiply a number by 10, like 3 by 10, it's 30. Good. Ignore my terrible zeros. By 10 again, by 10 again, by 10 again. Oh, I want to divide by 10. Oh, now I'm getting rid of zeros. Oh, I'm out of zeros. What do I do now? Oh, I put a decimal point there. Oh, I want to go further left. Now I start adding zeros in front. That would be if we had a negative power up there. Multiplying by 10, whether it be to a positive or negative exponent, allows us to move our number to the right and left at will as many times as we need to for as large or as small as it is. And thus, it's not times 9, it's not times 7, it's always times 10. We are in base 10. Okay, so let's dive right in. I'm going to close out my division property of exponents, last problem that I did before filming this. And let's talk about a very simplified example of a number that is small enough to write down and know its name, and yet it's a good way to start. I've got 5 as my first number. If you have a -5, you'd have -5. Times 10 to the third power means move your decimal point right 3 spots. 1, 2, 3. And then stick it there. We're going to stick zeros in between the spots. This is what's known as standard notation. And with no commas, because we never want to put commas in our answer, it even tells us this. Do not include commas. I simply just have to type to get this right the number I have in front. And again, if it's negative, put a negative. And then 1, 2, 3 zeros. This is a very simplified example because it does not have any additional digits other than the 1, 5 in front. If you have one digit and the rest are zeros, it's pretty simple for scientific notation. The next one is a good example. We're going backwards. So now I've got this 1. Again, if you have a negative in front, put a negative in front. If you don't, then don't. Like I'm not, so I don't. And then we need to put the times 10. Now, there are 3 ways of doing this. I'm going to show you all 3. In general, that's how my math class rolls. If you could do something multiple ways, I show you every way that I can. And then if you know another way to do it, please show me. And whatever way works for you, works for me. I just might eventually show you a faster or more concise way to get there, but really, to each their own. All right, there are these arrows that are hiding. You'll notice them all along. There's one. There's one, there's one, there's one, there's more over there. If you hit the one that's next to this division sign, right about the right middle of these icons, you'll see some different shapes and buttons pop up. Greater than or greater than or equal to, less than or equal to, not equal. We use these sometime. A plus or minus, that would have been useful in the quadratic formula. You'll get that in integrated 3. I want you to focus on these two here. They both mean multiplication. It says dot as multiplication or just multiplication sign. You can hit the X or you can hit the dot and then type your 10. To the power of is always this button here. The superscript it's called. And you can hit Control up to get there, which is also Shift 6. Shift 6. Woo! Puts your exponent up. And then I'm going to simply count how many digits do I have after the 1. Now notice what I'm saying. I'm not saying zeros. Coincidentally, they are 0, but really what we care about is how many digits after the first digit. So 1, 2, 3, 4, 5, 6, 7. So I put a 7 up there. That's very important because you're not always going to have problems where you have just one non-zero digit and a bunch of zeros. The third way you can do it, and I wanted to show you first that that works. And then check this out. So I've got my 2, and then I've got my 6 zeros. Instead of typing in 2 times 10 to the power of 6, I could simplify that whole thing to 2e6. Why? Because e is the calculator way of typing in times 10 to the power of what? So this simply reads as 2 times 10 to the power of 6. If that's too confusing, don't worry about it. Go back to this times 10. I just always like simplifying and shortening when we can, saving space. Number 3 is exactly why I told you to not think about zeros and instead think about the first digit, because we immediately have multiple digits that aren't 0. If you have a negative in front, put a negative as always. If you don't. I've got an 8 and a 1. Now here's what I do. If you have 2 digits that are not zeros, you must put a decimal after the first one. So I've got 8.1, and then I could do my times 10 to the power of, or I'm just going to keep using e, and then count how many digits you have after the first digit, including the 1. So I've got 3, 6, 9, 12. So I can put 8.1e12. It will also be accepted, as it will show you, as 8.1 times 10 to the 12th. Typing in the E version allows you to see both versions when I check it, so I'm going to keep doing that for the rest of the assignment. Number 4 is the first time we have an example of a negative power. Remember what I said at the beginning of my little mini lesson? If I have a negative power, it doesn't mean that it's negative out here. That's only if you have like a negative 7. Instead, it means that instead of adding zeros to the right, or instead of moving my decimal to the right, I'm going to go left. And with only one digit, I need to add 6 zeros, 6 matching this number up here, in front of my 7. 1, 2, 3, 4, 5, 6, 7. Oops. Let's try that again. 1, 2, 3, 4, 5, 6, and then goes the 7. Right after the first 0, put a decimal point. And here's how you can know whether you've done it right. If your cursor is over your decimal point, press the right arrow on your keyboard to match what exponent you have up there. So I'm going to hit it 6 times. Watch this. 1, 2, 3, 4, 5, 6, and boom. You can see it there blinking right in front of the 7. So I know that I am correct. We don't have to write it in scientific notation, so there's no E on this problem because we're writing in standard notation. All right, let's move on. All right, number 5. Finally, I have an example of a problem that has a negative in front. Notice, negative in front. Maybe you've already had like 3 problems. And you're like, Dylan, what do I do about this negative in front? I tried to explain it to you verbally, but now I get to actually show you. If the negative's in front, that's the first thing you type. And then we need to type the first digit that's not a 0. So for me, that's 1. Okay. Then you either hit your times 10 to the power of, or you're like me, you just hit E. Now notice, because we have a decimal now, remember we need a negative exponent. So I need another negative after the E. This does not mean the negative in front. That's this negative. This means that we're going left. And then you have a choice of whether you want to start in front of the 1 and count how many digits you go backwards till you get to this decimal point. Or I just count zeros, including this first 0. 1, 2, 3, 4, 5, 6, 7 zeros. So that's what I put. So either count the total zeros, which is including the 0 in front of the decimal, or you work your way backwards from the 1, the right side of the 1. All right, pause it if you need more time. Moving on to 6. This one's not negative in front, so I don't put it in front. We have 2 digits, so I'm going to put that 6.1. Then E, it's still a decimal, so I put the negative number. And then I count how many zeros. 1, 2, 3, 4, 5. Would also work to go from the right of the 6 backwards. You jump 5 digits, the 4 zeros after the decimal and the 6. All right. The last 2 problems are kind of fun because if you were to do this multiplication manually, it would be kind of a hassle. You'd have to convert this to like 4,000. This is 2 with 6 zeros. You multiply that number together, then you go backwards, convert it to scientific notation. Ugh, disgusting. Instead, if you have them both in scientific notation, here's all you have to do to multiply them. Take your first 2 numbers. I've got 4 and 2, so everything that's not a times 10 to the number, and multiply them together. Because this is a multiplication problem. 4 times 2 is 8, so I just type in 8. And then you could type your times 10 too, but for me, again, I'll just use E. And then remember, this is why I'm doing this right now. We just did multiplication and division property of exponent lessons. If you haven't done those yet, go back and do them. Remember that 10 to the third times 10 to the sixth, I can go and show you on the right, but just trust me if you don't remember, you add your exponents together. So 3 plus 6 is 9. So for you, add your exponents together, your little numbers above the tens. And that will give you your answer. You could once again put it with an E or put it with the times 10 to the power of your call. And finally is the division one. So we divide. What's 6 divided by 2? Again, I'll show you here just in case you have this on mute, just following along visually. Whatever number you get there, you transfer here. Then we hit our times 10 to the, or just E. And then remember what 10 to the 9th over 10 to the 2nd power is. We just did this. We subtract. 9 minus 2 is 7. So I put 7 there. All right. If you have done this correctly, you should see 100%. 8 out of 8. Let's submit it all so you can see this 100. All right, awesome. Well, this will officially end our little mini unit on multiplication and division property of exponents and scientific notation. I hope this video finds you safe, happy, healthy, and well, and best wishes in all that you do. Until next time, this has been Class Away from Class. Goodbye.